I'm all about that space, Yeah, it's pretty clear. I ain't commercial clear.
They have a live satellite data stream from NASA providing daily global imagery within 1 hour of its acquisition.
All the right places.
Their online educational resources have been accessed over 8,500 times from more than 150 countries in the past month alone.
They work with NASA, the European Space Agency and the German Space Agency.
They are building one of the most advanced and well-equipped small unmanned airborne systems, not only in Australia, but globally.
Their unmanned airborne system will require operators to achieve accreditation just shy of a private pilot's license.
They teach 5 undergraduate units, 4 postgraduate units, and specialist industry short courses.
Their student numbers have increased up to 2,500% over the past 5 years.
The unrivaled detail of their daily fire maps provides essential information for managing 3.5 million square kilometers of Australia's savannas and rangelands.
That space. I'm bringing rockets back.
Now you learned that we've got a live data stream from NASA and we're producing daily fire maps. And so last year as a visiting scientist, I was at the German Aerospace Center in Germany. And I was using that information to track a bushfire that was heading towards the Savannah Supersite in Litchfield National Park. And when I used that information, I was thinking about, well, there's actually quite a bit involved to produce this information. And then the idea came up that I might be able to illustrate that in Google Earth. So this is a first, so bear with me if it doesn't work perfectly, but we'll try our best. Yep. All right, let's assume we've got a fire in Litchfield National Park. It might look like this one, and we've got plenty of these fires here in Australia. And we got that satellite coming over, capturing an image of the Earth line by line, and building up that image that we use. That data then gets transmitted to a geostationary satellite, and from here it gets transmitted down to the ground station in White Sands in New Mexico in the US. From here, the data then gets transmitted across the whole of the US to the East Coast, to the Goddard Space Flight Center in Maryland. And this is actually where we get the data from, where we've got our live data stream from. So over the internet, we transmit that data. And just the other day, I learned that it actually goes via Hawaii and New Zealand, and ends up here in our data center, and ends up here within 1 hour of acquisition. And then it takes about another hour to process that data and make burned area maps available. And, well, I happen to sit in Germany looking at that data in front of my computer, or you could have a tablet or your mobile phone and get information about fires, current fires here in Australia. Yeah, and so we've got actually an archive of 15 years now, and we're expecting to get at least another 5 years out of these satellites. So we can start to look at long-term changes. But we don't want to just know where there is a fire, because a fire is not a fire. We want to distinguish different fires. And that's why we're not only looking at burned areas, we're creating maps of fire patchiness. And as a byproduct, at this stage, we get inundation maps, daily inundation maps, cloud maps, and also information about atmospheric water vapor, which we now combine with the fire information to get a better idea about how the fires behave and under which conditions they behave differently. Now, I've told you, or we've told you over the last 5 minutes, it's all about space, but actually, it's not.
this is our unmanned airborne system, or it's sometimes called a drone. It's helping us to bridge the gap between our field survey and satellite observations. This means that any measurements that we make here in the field today can be scaled up using satellite remote sensing to give us an idea of what's happening over border areas. The site's really interesting. We came here last week and it had just finished burning overnight. So now we've got some baseline data, and by continuously flying the site, that will allow us to look at the rate of vegetation recovery. So we can't achieve the same level of spatial detail that we can get with this UAS with any form of satellite or other platform. So it gives us that spatial detail, a frequency, and also the flexibility of image capture. Murphy's law of remote sensing states that whenever you want to go out and take measurements, the clouds always roll in. So that's a really big problem for satellite remote sensing, but for us with UAS we have the flexibility to either fly under the clouds or even just reschedule to later in the day or the following day as well. So that's a really important feature of it. But unmanned airborne systems are taking remote sensing research to a whole new level. I'm really excited to be part of working with this technology, and I'm constantly inspired by all the new potential applications that we can work with.